we need to talk about deepfakes. You know those AI-generated images that are getting so good, they're practically impossible to spot with the naked eye. But what if the secret to finding the fake was actually hidden inside the image itself? What if we could use the elegant, infinite complexity of mathematics to do it? Well, let's dive in. I mean, seriously, think about this question. If a synthetic image is visually flawless, our own eyes just can't be trusted anymore. So we need a way to verify what's real that goes way beyond human perception, one that doesn't just rely on spotting tiny glitches. So where do we even begin? Okay, first you have to appreciate just how good modern fakes have become. We're not talking about clunky Photoshop jobs anymore. AI generators can now create what researchers call high-quality synthetic images. And that means photos and videos that are, for all intents and purposes, indistinguishable from reality. This is a huge, huge challenge.
So, how are we fighting back right now? Well, the tools we have, they've got some pretty serious limitations. Let's take a look at the two main approaches people are using today.
So on one side, you have passive detectors. Think of these as digital detectives, scouring an image for tiny clues, the little artifacts that an AI might leave behind. The problem: as AI gets smarter, it gets way better at cleaning up after itself, basically making these detectors obsolete. On the other side, we have proactive watermarks, which invisibly tag an image right from the start. It's a really clever idea, but here's the catch. Most of them can only tell you if an image was messed with, not where or how. And that really gets to the heart of the matter. Our current tools are failing on two critical fronts. They don't have localization, so they can't pinpoint the exact spot that was faked, and they lack explainability. They can't show you the proof of why something was flagged. Just getting a simple yes or no answer is just not good enough anymore. But this is where things get really interesting. A fascinating new approach is taking its inspiration from the beautiful, complex math that we see all over in nature. The researchers behind a new method called fractal forensics had this brilliant idea. What if you could use the unique properties of fractals to create a totally unforgeable digital fingerprint? So, what even is a fractal? Well, you've seen them everywhere. Think of a snowflake, or the branching pattern of a fern, or even a jagged coastline. It's a pattern that just keeps repeating itself, no matter how far you zoom in. You just keep seeing the same basic shape over and over again. It's infinite complexity, all born from one simple, repeated rule. And it turns out, this is exactly why fractals are perfect for this job. For starters, they have infinite detail, which makes them nearly impossible for an AI to fake perfectly. Plus, each one is generated from a unique mathematical formula, kind of like a one-of-a-kind key. And you can even encrypt them to make them incredibly secure. It's basically the ultimate invisible signature. So, how do you take this elegant piece of math and turn it into a working piece of technology? Well, these researchers developed a system that transforms this idea into a really powerful, really practical tool for sniffing out deepfakes. The researchers used a fantastic analogy to explain it. They said to think of their fractal watermark like the hologram on your credit card. You know, it's durable enough for everyday use, you can swipe it, bend it, whatever, but if someone tries to tamper with it, it just shatters. The technical term for this idea is a semi-fragile watermark. The whole system is trained to know the difference between a benign change, like you saving a photo as a JPEG, which compresses the file a little bit, and a malicious change, like an AI completely repainting someone's face. It's designed to ignore the first one, but completely break on the second.
So here's the whole process in a nutshell. First, a unique fractal pattern is created. Second, that pattern gets invisibly woven into the entire image, from corner to corner. Third, if you do something normal, like compress the file to email it, the watermark stays perfectly intact. But, and this is the absolute key, if a deepfake algorithm messes with any part of that image, the fractal pattern in that specific area shatters.
And that shattering effect, well, that is what leads to the real breakthrough of this entire method. Because it's not just about knowing a fake exists anymore. It's about finding out exactly where it's hiding.
Because like we said, just getting a yes or no on whether something is fake, that's where all the current tools fall short. This new method takes a huge leap forward. The real magic here is localization. For what feels like the first time, a proactive watermarking system can tell you precisely which pixels in an image have been manipulated. So how on earth does it do this? The paper calls it the entry-to-patch strategy. Okay, so imagine laying an invisible grid over the entire image. That's the fractal watermark. Each little cell in that grid, which they call an entry, corresponds directly to a small patch of pixels in the actual image. Now, if a deepfake comes in and alters the pixels in one of those patches, boom, the corresponding entry in the watermark grid breaks. So by checking which grid cells are broken, you can create a perfect map of the forgery.
What you get at the end isn't just some label that says fake or real. No, you get a visual heat map laid right on top of the image, showing you with pixel-level precision exactly which parts were faked. Now that is true actionable explainability. And hey, the results really speak for themselves. The experiments show that fractal forensics isn't just good at localization, it also blows existing methods out of the water in pure detection accuracy. The data is clear. It's significantly more accurate than both the old-school passive detectors and even other leading state-of-the-art watermarking techniques. Okay, so this technology is obviously brilliant. But let's bring it back down to earth. What does this actually mean for the rest of us? Well, the implications here go way beyond just cool tech. This is about trying to restore some trust in what we see online.
This could become an absolutely essential tool for so many people. I'm talking about journalists who are trying to verify a photo from an anonymous source, social media platforms that desperately need to flag manipulated content automatically, scientists who need to be sure their data hasn't been tampered with, and eventually, for all of us, just trying to figure out what's real in our digital lives.
Ultimately, the goal here isn't just to play some endless game of cat and mouse with deepfake creators. It's about building a fundamental layer of trust and verifiability right into our digital world, making it just a little bit easier to believe what we see. And that really leaves us with a final fascinating question. Fractal forensics works because it embeds this complex, elegant mathematical solution invisibly inside the very data it's trying to protect. It just makes you wonder, what other massive digital problems, from cybersecurity to data privacy, could we solve by hiding some elegant math right there in plain sight? Thanks for tuning in.